We've toured a lot of worlds in our solar system here on SciShow Space. Most of the time, the visit hasn't ended well. Other planets and moons tend to be uninhabitable. But today, we're visiting someplace a little more friendly, Saturn's largest moon, Titan, which is one of the most Earth-like worlds in our solar system. Or olden-day Earth-like, anyway. That's because Titan has a dense atmosphere of nitrogen and methane, which is probably close to what Earth's atmosphere was like more than 3.5 billion years ago, before cyanobacteria started pumping oxygen into our atmosphere. When the European Space Agency's Huygens probe landed in 2005, it was humanity's first landing on any body in the outer solar system. Titan's around 1.5 billion kilometers from the sun. That's a lot farther than Earth's 150 million kilometers, so it's cold and dark. It's also almost impossible to see Titan's surface through its thick, orange atmosphere. The atmosphere is more than just dense, it's also huge, stretching 600 kilometers above Titan's surface. That's even higher than Earth's 480-kilometer atmosphere, even though Earth itself is more than twice the size of Titan. That's because Titan's gravity is weaker, about 14% of Earth's, so its atmosphere doesn't cling as tightly as ours. Because other moons don't really have dense atmospheres, astronomers used to think to figure out how big Titan was, they could just measure the big blob they were seeing through their telescopes. And by those numbers, it seemed to be the solar system's largest moon. Then, in 1980, Voyager 1 did a flyby and discovered the moon's huge atmosphere. Why does Titan have an atmosphere while other large planet-sized moons like Jupiter's Ganymede and Callisto don't? Well, astronomers don't know for sure. Astronomers think Titan's atmosphere seems to come from the gases released from inside the moon. It might have more of the stuff than other moons do, because more of it was trapped inside when Titan formed, but we don't really know why Titan was the lucky one. That's just one of the unsolved mysteries about Titan, and as we close in on the moon's surface, we spot another. The methane clouds. They're a lot like Earth's clouds in the sense that they go through a cycle that's mostly driven by sunlight. But instead of water, they come from the liquid methane on Titan's surface. On Earth, methane is almost always a gas, but on average, it's minus 179 degrees Celsius on Titan's surface, which is why methane's a liquid or a solid. So the methane on Titan's surface evaporates, condenses into clouds, and falls back down to the ground as methane rain, starting the process all over again. Except the same sunlight that keeps the methane clouds going should be destroying them. The sun's radiation should be breaking down Titan's methane molecules while they're in the clouds, so some process must be replacing them. We just don't know exactly what. Using our probe to look out over Titan's surface, we'd see lakes, rivers, and seas. Even though they're made of methane, Titan is the only world in the solar system, other than Earth, that we know has these big collections of stable liquid on its surface. And since conditions on Titan are close to methane's freezing point, we'd also see solid methane in the form of dunes and hills of rocky ice, showing signs of erosion from wind and rain. But there are a few things we don't know if we'd see on the moon. For example, researchers think Titan might have cryovolcanoes, volcanoes that erupt compounds like methane instead of molten rock. That would help free methane from under the moon's surface, which might be what's replenishing the methane the sun destroys. And if we could burrow under the ice on Titan's surface, we might also find huge oceans. As Titan orbits Saturn, the planet's gravity pulls on the moon unevenly, making the moon's insides move around. The heat from all that friction might make it warm enough for there to be liquid sloshing around under Titan's hard surface. So, researchers still have a lot of questions about this huge, weird moon. Hopefully, more clues from telescopes, the Cassini probe, and the Huygens lander will help answer some of them. Thanks for watching this episode of SciShow Space, which was brought to you by our awesome patrons on Patreon. If you want to help us keep making episodes like this, just go to patreon.com/SciShow.